Hello, welcome back to your channel of learning mathematics. Nobody is born perfect in mathematics. No. Nobody is born gifted in mathematics. No, these are all myths. Absolutely not. Anybody can be good in mathematics. Yes, provided your concepts have to be very strong. Your basic foundation has to be very strong. You should be hardworking, you should be consistent also. With the right concept, anybody, trust me, anybody can be good in mathematics. That's why I'm here to help you out. So I'm going to do a very special video for class 8 students today, that is understanding quadrilaterals, because this is a very important topic in mathematics. 8, 9, 10, 11, 12, it goes on. Okay, so it's very important. You have the right concept in the higher classes also. Quadrilaterals to what? Yeah, Ramsey, you can just do it very easily. Alright, because I'll tell you a secret actually. What happens is, higher classes students know, they are also not very clear with the concept of quadrilaterals. You ask them, they will not be able to tell you exactly what is a quadrilateral because they did not give much importance in class 7, 8 classes. But class 7 and 8 are very important because these classes contain all the concepts that are required for your build up to the higher classes. Alright, so that's why, as I say, I am here, we are here. Pick up your pen and paper, write down the notes. I'm going to give you the notes. Don't worry about the exercises. I will solve the exercises, don't worry. But as I say, concept, understanding becomes very important so that you can also do and visualize and imagine on your own. Okay. So, as I said, today we are going to do understanding quadrilaterals. That's under chapter 13 of progressive textbooks. Different textbooks, different chapter name. NCRT, I think it's chapter number 3. But that doesn't matter because in class 8, this chapter will be there because it is very important. But quadrilaterals, we are not going to do today, some other day. Tomorrow, day after tomorrow, we're going to do later on. Because, as I say, concepts. So today we are going to just study some geometrical concepts, clarify those concepts so that the picture becomes more brighter, and then we are going to jump into quadrilaterals. In this chapter, what we are going to have is, yes, first we will try to understand what do we mean by plane surface. Don't worry, these definitions will not be there, but we need to understand, as I say, you need to have that feel, no, you need to have that understanding concept. No? Then we will go for plane curves. Under plane curves, we have 4 types of curves. Don't worry, I'll tell you exactly what are these. After that only we will go to polygons. And after polygons, we will learn some properties of polygons in this chapter, some properties of polygons, different types of polygons. After that only we are going to quadrilaterals, where we will learn some properties of quadrilaterals, different types of quadrilaterals, special types of quadrilaterals, special types of quadrilaterals, again special types of quadrilaterals. But by the end of this playlist, the video of this chapter, everything will be clear to you. Trust me. So, chalo, notes are very important. So, pick up your pen and paper, start writing down small things. Not only the exercise you can also do. Exercise you can also do. If you understand, you can also do on your own. You don't need anybody's help. Okay? So, let's understand. First thing is, okay, let me start with the name of the chapter, that is understanding quadrilaterals. So we are going to understand quadrilaterals. That's so simple. But I'll get back to that quadrilaterals some other day. I mean, not some other day. Maybe after 1-2 videos. Alright, so this is out. Now, we have to first understand what do we mean by plane surface. Plane surface. So a plane surface is a surface that is plane. Yeah, seriously, plane surface. What do we mean by plane surface? The board, this is also a plane surface. It's not up and down like this, isn't it? It's a plane surface. So a board is also considered as a plane surface. Your notebook, your desk, your table, the mobile screen, these are all plane surfaces. Alright, so plane surface simply means that only. Okay, then we have plane curves. What do we mean by plane curves? Now from here, let's start slowly. Alright, so what do we mean by plane curves? Now, imagine this is our board, this is a plane surface, and then maybe we have some points. 1, 2, 3. You have written down, no, this map? You can pause the video, write down. Okay, suppose I have 3 points. So on the plane itself, I can join this with my free hand. No, I'll not use scale. So this is known as a plane curve. No, got it? No, just joining the points. You can also have straight lines. You can even use scale also. Maybe the points can be like this, so you can use a scale. So this is also a plane curve. Alright, got it now? So plane curve means it can be a straight line or it can be a curved line also, no problem, which is formed or which we get by joining points on the same plane, not on another plane, same plane. So not one here and one there, no, on the same plane. Alright, so that is what we mean by a plane curve. And after that, what we have is, we have 4 types of plane curves. Simple curve, simple to simple. Complex curve, complex to complex. Open curve, open means open. Curve, closed means closed. That's how easy it is. That's how easy it is. If we just use a little bit of our common sense is very important because it is very uncommon. Okay, so common sense is very important. So what do we mean by simple curve? Let's start with this. What do we mean by a simple curve? A curve is called a simple curve if when we join 2 or more points, none of the curves come back and intersect another curve. That means they will all be like this. This is called a simple curve. Or maybe we can have points like this. So I can just join like this also, no problem. So these are called simple curves where no curves will be like crossing each other. They will not be crossing each other. You will understand that in complex curve, what I mean by crossing each other. Because complex curve is that curve where when we try to join the points, definitely one or the other curve will be crossing each other. That means, now you will understand the meaning of simple curves also. Suppose I have some points here. Then maybe when I'm just joining the curves with my free hand, then I do like this. Then suppose then you can see that it crosses. This kind of curves are called complex curves. Okay, some of you must be thinking, what means this point though, I can just join like this, like this, like this, like this. Yes, then in that case, this will be called a simple curve. In that case, it will be called a simple curve. Understand the bigger picture. Understand the bigger picture. Okay. Complex curve will be those curves which will be like, something like this. They will cross each other at one point or the other point. Those kind of curves, like this also again, or like this. This kind of curves are called complex curves. Simple curves, it will not touch again. It will not come back again and then touch the curve. Those kind of curves actually are called simple curves. With the curves where they cross each other are called complex curve. Then we have open curve. Open curves are those curves which do not close each other. Something like this. This is also an open curve because it's open. You can put your dal, chini, sugar, everything inside and then cook also. No problem. It's an open utensil. So that's called an open curve. Open curve. Open curve. Something. It can be also like this also. So this is also an open curve. Understood, no? So these are known as open curves. Even like this also. These are also known as open curves where it's not closed. When you understand the concept of closed curve, you will understand the concept of open curve here also. Closed curve are those curves which are like bounded, closed. That's the meaning. Closed. So there is no opening at all. So these curves are called closed curves where the initial and the final point will come and meet with each other. Initial and final point means what? Initial means starting point. Final means last point. So suppose if this is the starting point. So I start, I do whatever I want, go, but again I come back, final point, again I come back. So I started from here, I came back here, I joined. So see, it is closed, see? Closed, no opening, gate closed, so the gate is no more open, you cannot enter anymore. Those kind of curves are known as closed curves. Got it? Open curves means where the gate is always open, you can enter anytime, no problem. Okay, so that's the meaning of open curves. I think that's clear. Okay, so these were some simple terms which that's why I quickly did that revision, because this is already done in class 6 and 7. Okay, class 6 and 7. But chalo, revision to bantai, so that's why I gave you the revision. Next is polygons or polygons. Again, write down the definition. Definition is very important. So it's a simple. It's a simple closed curve. What was a simple curve? It doesn't cross each other. No, it doesn't cross each other. Alright? Goes, doesn't cross. Alright? A simple closed curve made up of line segments. A simple curve made up of line segments is called a polygon. Is called a polygon. Is called a polygon. A simple closed curve. Simple, closed. We have already just seen what is simple and closed. A simple closed curve made up of line segments is line segments, not curves. Line segment is called a polygon. That means, suppose you have some points. So if I join, it has to be closed. So if I join these points, then it's closed. Now it's closed and it is made up of line segments. Then this will be called as a polygon. But again, if you have like closed surface, again, but maybe I do like this. Apple or love, heart shape. Then in that case, this is closed curve, of course. This is also simple curve, yes, but it is not a polygon. Alright, sir, you are just telling us simple curve, closed curve is a polygon. Yes, this is also simple, this is also curve. Then why is it not a polygon? Yeah, because it has to be line segments though, not curves. So this is not a line segment now. We don't see lines here, we see curves, which are not line segments. Line segment means sida, no? Line segment, everybody knows. Lower classes, we have already studied that. Line segments. What do we mean by a line segment? So a polygon should be, yes, a simple closed curve, but should be made up of line segments. Then we call that figure in general as polygons. Of course, we have different types of polygons. We'll be studying about that. Maybe this time you have 4 points. Then you join line, chalo, polygon. Maybe you have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Polygon. Closed curve joined by all straight lines. Then it is called a polygon. And the line segments which you get by joining 2 points. Now, two points. This also 2 points. This also 2 points. These are called as sides of a polygon. Sides. So these are also known as called sides of a polygon. So here, how many sides do we have? 1, 2, 3. We have 3 sides. Here 1, 2, 3, 4. We have 4 sides here. And here, how many sides do we have? 1, 2, 3, 4, 5. Okay, this one is also there. So 1, 2, 3, 4, 5, 6. We have 6 sides. That's what we mean by sides of a polygon. Okay. Then of course, some simple things about polygons we also have, that is called as interior and exterior of a polygon. Interior and exterior of a polygon. Interior means simple, very simple. Let me not waste time on these topics. You can also read your textbook, you will also understand, but let me just tell you at least. Interior means inside, exterior means outside, simple as that. So let me just draw a rough polygon with 4 sides. 1, 2, 3, 4. So side 1, let's say side 2, let's say side 3, let's say side 4. So it has 4 sides, chalo, 4 sides. So interior means inside, so this is the interior of the polygon. Exterior means outside, so this is the exterior, all this. These are all the exteriors of the polygon. Got it? Chalo. Then we have diagonals. Definitions and all you will have in the textbook. If you wish to read, you can read the textbooks. I'm just here to give you the concept only. Alright? Diagonals are, you can see the textbook. Okay, I'll just give you. You can write down. What do you mean by diagonals? A line segment that joins any two, a line segment that joins any two, the line segment, diagonals of a polygon. Okay, diagonals of a polygon, G-O-N. A line segment that joins any two non-adjacent sides, non-adjacent sides. A line segment that joins any two non-adjacent sides is called a diagonal, or not only non-adjacent sides, maybe even vertices. Okay, vertices, maybe even by joining vertices not lying in the same line. Vertices not lying in the same line. So a line segment that joins any two vertices not lying in the same line is also called a diagonal. Vertices, so I hope you know, lower classes. As I say, we have already studied. Vertices means the point where two lines meet. This line is meeting and this line is meeting at this point. This is called a vertex. V-E-R-T-E-X. Vertex. Since if we have more than two vertex, we call that in plural form. This is singular, so in plural form we call it as vertices. So this figure has 4 vertices. 1, 2, 3, 4. Chunga, point, no? 4 vertices. Alright. So a line segment formed by joining two vertices, any two vertices, but they should not be lying in the same line. So this and this I cannot join because it's already the side. So but this and this I can join. Then we get a diagonal. That is called the diagonal. Similarly, or in other words, a line segment that joins any two non-adjacent means the two sides should not be neighbors. Okay, should not be neighbors. Adjacent, see, we have already studied all this. You have already studied this in your lower classes, but I'll again tell you, adjacent sides means this side and this side. See, they are near to each other, so they are called adjacent sides. This and this adjacent sides, this and this adjacent sides, not neighbors. But this side and this side, no, they are not neighbors. They are far away from each other. They are not joined together, so they are non-adjacent sides. So I can join like this. I can join like this. These are called diagonals. Alright, so I hope the concept of diagonal is clear. A line segment formed by joining two vertices not on the same line. Suppose like this, we have 1, 2, 3, 4, 5, a pentagon. What is a pentagon, sir? I'll tell you, don't worry. Now let's draw some diagonals. Okay, let's draw some diagonals. Remember, these are the vertex points. 1, 2, 3, 4, 5. So draw them. Try to draw the diagonals. Chalo. Try to draw diagonals. Come on. What did I say? You can draw diagonals from one vertex to another vertex point, but they should not be lying on the same line. So I can use this, I can use this. Not on the same line. So I can join. One diagonal formed. Again, I can join this too also. Another diagonal formed. Can I join this? No, because they are all lying on the same line. But I can join this, another diagonal form. Oh yeah, I can join this also, again diagonal form. So the more sides you have, the more vertices you have, the more diagonals you will also get. Alright, so that is what we mean by diagonals of a polygon. Then we have two types of polygons. Okay, we will be having two types of polygons. One is called regular polygon. The other one is called where there is good, there is bad also. Where there is good, there is evil. No? So one is called regular polygon, one is called irregular polygon. A regular polygon is that polygon in which all the sides of the polygon are equal in length. What is a polygon? A polygon is any shape or figure. Forgot. What is a polygon? Check your notes. What is a polygon? Polygon. A simple closed curve made up of line segments is called a polygon. Now, so let's say like this. So I have a 4-sided polygon joined by 4 line segments. Here, if all these sides 1, 2, 3, 4, if all these 4 sides are equal in length, then we call that as regular polygon. But if your polygon is like this, one is too long, then you will see that their lengths are not same, different though. One is long, one is short. So when you have this kind of polygons, then these are called irregular polygons. Irregular polygons. Got the concept of regular and irregular polygons? If yes, we'll move on. Okay. Alright, then again, what can we learn more about polygons? Polygons. Yes, we have concave and convex polygons. Concave and convex polygons. Concave and convex polygons. What are concave and what are convex polygons? Try to understand this. Okay, you can read a definition in the textbook also, but see, suppose any polygon I'll draw, and this one also, this is also polygon. I'm joining by line segment only. Vertices. Also vertex. How many sides here? 1, 2, 3, 4. Here 1, 2, 3, 4, 5, 6. Now concave polygon will be like if you have 2 points inside the interior of the polygon. Let's say here and here. Now both these points are inside the polygon though. Yes or no? Yes. Join them. Join. So when you are joining those 2 points, it is again in the interior of the polygon only. Locked down, so nobody is going out. But there are some law breakers also. Suppose see, inside or not? Inside, yes. This one also inside or outside? Inside. Join them, straight line. I cannot join like this. This is not a straight line, this is smiley. So, no. Okay, the only option is joining. Now you see what happens. When I was joining them, what happens? I have to go outside. This is the exterior of the polygon though. So when I was joining the interior of the 2 polygons, you see, I had to go outside. This kind of polygons are called convex polygons. This kind of polygons are called concave polygons. Sorry, this is called a concave, C-O-N-C-A-V-E, and this is called convex polygons, C-O-N-V-E-X, convex polygons. Convex inside, concave outside. Okay, sorry for that. Alright, convex. So once again, a polygon is said to be convex if the line segment joining 2 points in the interior lies in the interior. Concave polygon, a polygon is said to be concave if the line segment joining any 2 points in the interior does not lie completely within the polygon outside. Got it? Okay, so once again, quick recap. Convex means you have 2 points in the interior of the polygon, something like this. 2 points inside. You join them, it's in the interior. 2 points, interior. 2 points are interior, but you join them, I have to go outside. Concave. Interior, convex. If it goes outside, concave. Alright, concave, convex. Okay, got that? Alright, okay, so concave, convex and concave polygons. Okay, so the last topic for today, ready for it? Types of polygons. I have to finish this in one video, so please bear with me, just 5 more minutes. Types of polygons. Types of polygons. In the classroom, you could see for 40 minutes. Chalo na 30 minutes, so it's okay. Come on. Types of polygons. Once again, convex polygons. A polygon is said to be convex if the line segment joining any 2 points in its interior lies within the interior. Concave. A polygon is said to be concave if the line segment joining any 2 points in its interior does not lie completely within the polygon. Now, types of polygons. Types of polygons. Depending on the number of sides. The smallest polygon that we can have with the smallest number of sides is what? 3. And its name, I'll just write in short. Its name is called triangle. Tri means 3 in mathematics. Tri means 3. So triangle. So this is the smallest polygon that we can have. Okay, close, because polygon has to be close. We need at least 3 points. So if the number of sides is 3, then the name of the polygon is called as triangle. Example, like this. If there are 4 sides, write down. If there are 4 sides, yes, that is what we call Quadrilateral, and that is what exactly we are going to be studying in this chapter. But as we know, we at least need to know the different types of polygons, then it's better to proceed according to that. So quad in maths always means quad means 4. So this will be a polygon which will have how many sides? 4 sides. Okay, a quadrilateral having 4 sides. Then we have a quadrilateral that has 5 sides. That's called penta. In maths again, penta means 5. Pentagon. So this will have 5 sides. You can draw in your own way. 1, 2, 3, 4, 5. Not exactly, it has to look like this. Any figure, closed figure drawing by line segments having 5 sides. Any 5 sides, that is called as a pentagon. Okay, rubbing it off, pause the video. Chalo, there. Alright, then we have some more again. I'll give you all today. Okay, last, just 1 or 2 minutes. Hurry up. 6, number of sides. Again, I'll just write a number of sides. So 3, 4, 5, done. When you have 6 sides, we call that as hexa. H-E-X-A. Gone. Hexa means 6 again. Hexagon. So it will have 6 sides. So like 1, 2, 3, 4, 5, 6. Basically, it's like the standard form. It can be any figure with 6 sides is called a hexagon. These are standard models. Any figure having 7 sides, heptagon. H-E-P-T-A. Heptagon means 7. Heptagon. H-E-P-T-A. Heptagon. So 7 sides. So maybe 1, 2, 3, 4, 5, 6, 7. No? 7 sides. Okay? See? 7 sides. That's called a heptagon. 8. Octagon. O-C-T-A-G-O-N. 8 sides, we call it as octa. Octa again means 8. Octagon. So octagon can be of 8 sides. So like, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. That's called an octagon. I'm not very good in drawing, so please excuse me with that. Okay? Okay. Then we have 2 more. 8, 9, 10. Then if the number of sides we have when we count and we get 9 sides, that is called nonagon. N-O-N-A. Where do we get all these names? I also don't know, but no, they call it nonagon, so let's also call it as nonagon. 9 sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sides, no? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. No. Lastly, 10 sides. Deca. 10 we always say deca, no? Multiple of 10 in mathematics. Decagon. 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides, okay? Any figure with 10 sides, man. Decagon. Okay, so that's the basic roundup introduction of this particular chapter. Understanding quadrilaterals, but today we discussed about the basics and the polygons only. Tomorrow, the next video, will be a little bit more about properties of polygons, and then exercise solving will be there. After that, slowly we will go to quadrilaterals. I'm sure you're going to like it. Alright, so that's enough for today. Ooh, chalk. That's enough for today, my dear students, my dear beloved students. If you have liked the video, please give me a like. Please give me a like also. Subscribe also. Okay? Alright then, I'll be coming back with more videos. Bye-bye. Take care.